This is actually only my second year at short course, so I was kind of nervous when Andy asked me to give this presentation. But I'm grateful for this opportunity, and hopefully I can answer some questions that you have on roller compacted concrete. So first I'll start off, this is an overview of what I'm going to talk about today. I'll start off with a brief introduction to roller compacted concrete pavement and how it compares to conventional concrete pavement. Then I'll go over some applications and some successful cases of construction here in Texas. And then I'll go into TxDOT's first RCC project that actually started earlier this year in the Brownwood District. And finally, I'll go over some information, more information that we need to gather about RCC pavements before we can fully integrate this into our DOT uses. So let's get started with a short introduction here. So roller compacted concrete pavement is like conventional concrete pavement in that you're using the same basic ingredients. You're working with water, cement, coarse and fine aggregate. And because you're using these same ingredients, you can expect similar mechanical properties out of roller compacted concrete pavement. But again, just like conventional concrete, curing is critical, so you're only going to get these durability and strength benefits if you take care of this concrete while it's curing. On the flip side, it's also a little bit like asphalt pavement in that you have a similar aggregate gradation. You want a very well-graded combined aggregate with the goal of decreasing the amount of voids in your matrix so that you're using as little binder as possible. You also have similar placement methods. You're using an asphalt type paver and then rolling it to compaction with a vibratory roller. So you put these characteristics together and what you get is RCC pavement. You have a stiffer than zero slump concrete. It's not conventional concrete that's zero slump. There are some additional engineering designs in there. It's typically plant mixed and transported in dump trucks and placed with an asphalt type paver and then rolled to compaction and again cured with water or a compound sprayed on. Alright, so now let's talk a little bit about the differences between conventional concrete and roller compacted concrete. So first are the material proportions. In conventional concrete you have a little more than 20% paste in there versus RCC where if you do your aggregate gradation correctly, you should end up with a little bit less than 20% paste. Also, you might notice that the fine and coarse aggregate proportions almost switch. You're using more fine aggregate to fill in those voids in your coarse aggregate so that you can really get those benefits of a dense matrix and not have to use so much paste. So because of these different proportions, you get, there's differences in workability, paving, and consolidation as well. So with conventional concrete slip-form paving, you have a plastic and flowable mixture, and it's designed that way so that it can be manipulated and consolidated with internal and surface vibrators on the paving machine. But it's still stiff enough to maintain its shape after the paver has passed. Also, conventional concrete slip-form paving is usually completed in one pass, unless you have a reason to do multiple lifts, but it's usually just one pass. And roller compacted concrete has the consistency basically of damp dirt. If you look at it from far away, it may look dry. It doesn't look like it has any water at all, but it does. It has enough fluidity to distribute the paste under the vibratory rollers, but it's stiff enough to support those vibratory rollers as it's compacting the pavement. Another difference is that roller compacted concrete is sometimes laid in multiple lifts if your pavement thickness is going to be over 10 inches. And this is because you want to be able to compact the layer fully. If you get any thicker than 10 inches, you're only going to get compaction in that top layer and you won't reach the bottom. Reinforcement is also different in roller compacted concrete in that there is none. You don't have any dowels, any steel, nothing is in there. In conventional concrete pavement, you always have something, whether it's tie bars, dowels, longitudinal, transverse, there's something in there, but not so in roller compacted concrete. And finally, finishing is different. Conventional concrete pavement, you have tining or carpet drag to get your finished surface, whereas roller compacted concrete, there is no finishing. You roll it, and that is your final surface. You may do some diamond grinding in there, but most of the time, the rolled surface is either the writing or the parking surface. All right, so now some advantages of RCC pavement. You get the durability benefits of concrete, as long as you cure it correctly, which you can see there's a water truck here spraying water on some day-old pavement there. So as long as you cure it correctly, you can expect the same durability that you would get out of conventional concrete. Also, you may benefit from faster construction. Since you're using an asphalt type laydown method, it goes a little bit faster, but you still need to give it a few days to cure, just like concrete pavement. Also, you may have some potential cost savings in that you're using more of the cheaper stuff. You're using rocks and sand and less cement. And no steel, no reinforcement, and you have typically a quicker construction time. And also with our eye towards sustainability, as green and sustainable movements gather traction in DOT applications, this may become important in that RCC has a higher solar reflectance. It's not absorbing as much of that heat during the day as the darker pavements do. So you can decrease your effect, the heat island effect in cities. All right, so now let's talk about where we can use RCC pavement. So because you're paving in long continuous strips and there's a good amount of equipment involved in this process, large open areas are the easiest for construction. So these are ports, industrial facilities, parking lots, equipment storage. Anything with big open areas where it's easy to get your equipment in and get going. So an example of this would be in the Port of Houston. They used 3 different pavement designs because they were working with different loading conditions. So depending on whether it was mostly truck traffic or maybe these cranes for these containers or the containers themselves, they had 3 different pavement designs with thicknesses ranging from 14 to 18 inches. And again, like I said before, when you get above anything more than about 10 inches, you want to do 2-lift paving. So here's a picture of their 2-lift paving operation. So with this operation, what you need to do is lay down your first course of concrete pavement and have your roller right behind that paver, because you want to roll that as soon as possible. That way you can get the second lift right on top. The port estimates that RCC shortened construction by as much as 4 months. And here's a good example of the kind of mechanical properties you can get out of roller compacted concrete. You have a 7-day compressive strength of 4,400 psi and a 7-day flexural strength of 570 psi. Pretty typical of concrete pavements. So another example of an application of concrete pavements are for slower speed traffic. These are your arterial and local streets, shoulders, things like that. So a local example here, well, not so local, but Texas related, is in the city of San Angelo. They replaced a few streets with RCC pavement and diamond ground the surface for smoothness. And the city seems to be very happy with this construction. They give raving reviews for this type of construction, so they would definitely use it again. So a little further away is the Georgia DOT. They replaced 34 shoulder miles of I-285 in Atlanta with RCC pavement, 6 to 8 inch thickness, and they did it in a couple of weekends. only closing the outside lane here and constructing like that. So another thing to note about roller compacted concrete is that it may be difficult in tight right-of-way situations. They were able to make it work, but you have to think a little harder for when you have tight right-of-way situations. And again, here, they were able to grind in rumble strips into this RCC pavement. So it's just like anything else. All right, so now a brief introduction into TxDOT's first RCC project. It started earlier this year in the Brownwood District. It's an I-20 or two I-20 safety rest areas in Eastland County. They're using 12-inch RCC on cement stabilized base, and that's going to be part of the parking lot or truck parking and some portions of the entrance and exit ramps. So as part of this project, we developed a special specification 3258 for roller compacted concrete. I just want to point out a few interesting items in this specification. First, we call out a pug mill or central rotary drum mixer, and this is because roller compacted concrete cannot typically be mixed in ready-mix trucks. You need a little more mixing energy because the material is so dry. It takes a good amount of energy to get it mixed up consistently. We also call out an asphalt type paver capable of attaining 90% compaction, and this is in making sure that you can get the full compaction with your roller in a quick enough time. That way you can lay a second lift if necessary or get your curing compound on. Field testing for roller compacted concrete includes density measured by TxDOT method 451, which is the nuclear gauge density, and compressive strength cylinders. So these aren't normal compressive strength cylinders. Since this material is so dry, you can't rod it or vibrate it. You have to use a vibratory impact hammer, which you put the material in a steel 6x12 mold and you use this hammer to compact it. We also have two standard combined aggregate gradations, and the purpose of these is to again get that dense graded aggregate. And also you'll notice that the main difference between these two, here we have a surface course and a base subcourse, or base subbase. And the main difference between these two are here the fines. And the reason for this is with the surface course, you want to fill in any voids at the surface. You want to make sure that you have enough fines to give you a good solid surface. And finally, mixture proportioning for RCC is a little bit different in that you're using a modified Proctor test with 3 different cement contents and various moisture contents to find an optimum dry density, or a maximum dry density for different cement contents. And then you're casting compressive strength cylinders, again according to ASTM C1435, and breaking those and finding your optimum cement content for your application. All right, so after all of this, why isn't RCC everywhere? Why haven't we used it so much? And the reason is because currently available RCC design guides like RCC PAVE and the U.S. Army Corps of Engineers design method are not applicable for our projected volumes or speeds. They're made for industrial yards and low volume, low speed traffic. So what we really need answered is, how will concrete pavements hold up under heavy truck traffic at relatively high speeds? And this is it's a big question. We need to know if aggregate interlock is going to be enough for load transfer, and also our typical base designs going to be equivalent to what is needed for RCC pavement, or do we have to change that around? So the latest version of the TRB construction journal has published a great article about RCC construction in Arkansas. And this article covers RCC construction on a rural road in Arkansas that has seen an increase in truck traffic due to the natural gas exploration of the area. So as the volume of traffic on that road increased, they realized that they needed to change it up a little bit. So they thought RCC was a good way to go. And this paper covers their design process and construction process. And it was published they were able to get a 6-month survey into this article. And at 6 months after construction, they saw limited cracking. And the most common distress were pop-outs from 1 to 4 inches in diameter. They also saw unraveling at longitudinal joints, but they believe that most of these problems can be addressed through mixture proportioning and construction methods. So finally, in summary, RCC pavement provides long-term durability of conventional concrete as long as you take care of it properly. You do your due diligence with mixture design and curing. And it can also be constructed relatively fast. But again, you still need a few days before you can put full traffic on it. Successful and proven applications of RCC include heavy industrial areas, arterial streets, local streets, and shoulders. And we have some good examples of that here in Texas. So I urge you to contact some people and if you have any questions. Also, TxDOT has a special spec for RCC pavements. So if you have any ideas of projects that you want to try to include this in, we have a basis to start from. And also, we need more RCC data for heavy repetitive loads. We won't be able to fully incorporate this into our TxDOT designs until we get that information, until we really know how it's going to hold up. And that's all I have for you today. So thank you for your attention, and I'll take any questions. Yes, sir.
How economical would it be, say, an RCC road, say you wanted to put an RCC on an FM or an RM, put, say, 5-inch RCC as opposed to, say, 2-inch asphalt?
There are, oh, I'm sorry. The question was, how economical would it be to lay, say, 5 inches of RCC instead of 2 inches of asphalt on an FM road? There are studies that document that. However, right now I can't give you numbers or give you any solid proof, but I will get your name and I can get you those studies. Are there any other questions? Yes, sir.
Rachel, is there any consideration for saw cutting to control a cracking issue?
Okay, the question was about saw cutting to control cracking, and yes, there are guidelines for saw cutting. The industry standard, I think, is about 15 to 20 feet to control cracking, but there are studies that show that sometimes you may need to that can be adjusted either shorter or longer depending on how acceptable it is for you to have some minor cracking in between. Is there another question?
I'd be really kind of concerned, trying to stick these 2 layers together, you put 2 5 or 6 inch layers.
Mm-hmm.
Is there something in the spec that helps you make sure that the layers won't together?
The bonds, yes. There is a time limit in between how quickly you need to get that second layer on top, and I believe it's an hour between the first and second. Yes, and again, that's an hour to get it laid down, compacted, and then the second layer put on top. So there is a time limit in the spec for that.